Good morning, my dear students of second secondary. Today's lesson is called one-to-one function, and this lesson is given only for scientific section. Let's start. The one-to-one functions. Take care, the arrow diagram from x to y represents a function f of x. Function f of x, its domain is x and its codomain is y. Take care, the function, the first arrow diagram represents a function, its ordered pairs are a1, b2, c and 3. Take care, each element of set X has only one image in set Y. Also, each element in set Y appears as a second projection in the ordered pairs once only. Here the function A1, B2, C and 3. Take care. All the terms of the set Y appeared as a second projection in the ordered pairs of the relation once only. Take care, 1 didn't repeated in the ordered pair, also 2, also 3. This function is called one-to-one function. The second function, its ordered pairs are A1, B1, C and 3. Take care. The number 1 of set Y repeated twice in the ordered pairs of the function. Then the second arrow diagram represents a function, but this function is not a one-to-one function because there is an element in set Y repeated twice in the ordered pairs of the function. How can we use the graph of the function to determine if this function is one-to-one function or not? In the first graph, this graph represents a function of the second degree. There is a horizontal line test, and this test you can draw, in this test you can draw a line parallel to x-axis. If this line intersects the curve at 2 points, therefore, if this line intersects the curve at 2 points, therefore this function is not one-to-one function. In the second graph, I will draw a line parallel to x-axis, and this line intersects the curve of the cubic function at 1 point. Therefore, this function is one-to-one function. If a horizontal line is drawn parallel to x-axis and cuts the curve at 2 points, therefore this function is not one-to-one function. If a horizontal line drawn parallel to x-axis and cuts the curve at 1 point, therefore this function is called a one-to-one function. Determine if the function f of x equals 2x minus 3 is one-to-one or not. Let a and b belongs to the domain of this function. I will find f of a, which equals 2a minus 3. Also f of b equals 2b minus 3. Then I write f of a equals f of b. Then 2a minus 3 equals 2b minus 3. Then I will cancel negative 3 with negative 3. Therefore 2a equals 2b. Therefore a equals b. I'll divide the left hand side and the right hand side by 2. Therefore, I will get the final result a equal b. Therefore, this function f of x is 1-to-1 function. Another example. F of x is written as 3x minus 5 over 4x minus 3. I write f of a, let a and b belongs to the domain of f of x, and I write f of a equals f of b. F of a equals 3a minus 5 over 4a plus 3, and f of b equals 3b minus 5 over 4b plus 3. There is something wrong in the problem. It's 4x plus 3. Then f of a equals 3 minus 5 over 4a plus 3. F of b equals 3b minus 5 over 4b plus 3. You should write f of a equals f of b. Then 3a minus 5 over 4a plus 3 equals 3b minus 5 over 4b plus 3. I'll try to simplify the left hand side and the right hand side. Then by using a cross multiplication, 3a minus 5 multiplied by 4b plus 3 and 3b minus 5 multiplied by 4a plus 3. Then 12ab minus 20a, 12ab minus 20a plus 9b minus 15 equals 12ab plus 9a minus 20b minus 15. Then negative 20a plus 9b equals 9a minus 20b. Then 9b plus 20b equals 9a plus 20a. Then 29b equals 29a. A equals b by dividing both the left hand side and the right hand side by 29. Then a equals b, and this function is 1-to-1 function. I'll try to simplify it again. 3a multiplied by 4b equals 12ab. 3a multiplied by 3 is 9a. Negative 5 times 4b, negative 20b, negative 15. Then 20, then 12. AB plus 9b negative 20a minus 15. I'll collect the like terms. Firstly, I will cancel 12ab with 12ab and the negative 15 with negative 15. Then the remainder is 9b minus 20a and 9a minus 20b. I'll collect letter b with each other, also letter a with each other, then 9b plus 20b, then 9a plus 20a. Then 29b equals 29a. I'll divide both the left hand side and the right hand side by 29, then a equals b. Therefore, the function f of x is 1-to-1 function. F of x equals 2x minus 1 over x minus 2. Take care, if the function is an odd function, if the function is a first degree or of third degree, then this function is one-to-one function. I write f of a and f of b. Let a and b belongs to the domain. Let a equals b. Therefore, f of a equals f of b. F of a 2a minus 1 over a minus 2, and f of b 2b minus 1 over b minus 2. Here, let a equals b, and the 2a minus 1 over a minus 2 equals 2b minus 1 over b minus 2. Then 2a minus 1 multiplied by b minus 2 equals 2b minus 1 multiplied by a minus 2. I'll simplify the left hand side and the right hand side. Then 2a multiplied by b equals 2ab minus 4a. Negative 1 times b equals negative b, and the negative 1 times negative 2 equals positive 2. Also 2b times a 2ab. 2b times negative 2 equals negative 4a. Negative 1 times a negative a, and the negative 1 times negative 2 equals positive 2. Negative 4a minus b equals 4b minus a. Therefore 3a equals 3b. I'll collect letter a with each other, also letter b with each other. Therefore 3a equals 3b. Again, this step, negative 4a minus b equals 4b minus a. I will move negative 4a to the right hand side, also 4b here. This is negative 4b minus b. Again, I'll erase this step. 2ab minus 4a minus b, and negative 1 times negative 2 equals positive 2. 2ab minus 4b, it's a 4b minus a, this is 4b, minus a, and the plus 2. Therefore I'll cancel 2ab, I'll cancel also positive 2, and the remainder negative 4ab, negative 4a minus b equals negative 4b minus a. Here, negative 4a minus b equals negative 4b minus a. Then I will move negative 4b to be positive 4b minus b. Here negative 4a is 4a minus a. It's 3b equals 3a. Then I will divide it by 3. Therefore a equals b as it is written using the PowerPoint. Therefore this function is one-to-one function. Another step, another example, f of x equals x squared. Take care of the function is an even function, therefore it is not a one-to-one function. Let's start to prove that the quadratic function is not a one-to-one function. Let a and b belongs to the domain. Let a equal b, therefore f of a equals f of b. F of a equals a power 2, f of b equals b power 2. I write f of a equals f of b, therefore it is written here a squared equals b squared. I'll try to simplify this expression, then I'll put a square root to both sides, left hand side and right hand side. Therefore a equals a positive or negative b. Here A has two values, b and negative b. Therefore, the function f of x is not one-to-one function. Another example, f of x equals x squared minus 5x plus 6. Let a and b belongs to the domain. Therefore, f of a equals, I'll put f of a equals f of b. F of a is a squared minus 5a plus 6. Also, f of b is b squared minus 5b plus 6. A squared minus 5a plus 6 equals b squared minus 5b plus 6. Here, I will cancel positive 6 with positive 6. Then a squared minus b squared minus 5a plus 5b equal 0. I'll try to simplify this expression. Here again, I will cancel 6 with 6. Then the remainder a squared minus 5a minus b squared plus 5b equals 0. Then a squared minus b squared minus 5a minus 5b. Here this expression is written as a difference between two squares, and this expression can be factorized into a plus b and a minus b. Minus 5, a minus b. I'll take 5 as a common factor. Then 5 multiplied by a minus b. Here I'll take a minus b as a common factor, and therefore the remainder will be a plus b minus 5 equals 0. Therefore a minus b equals 0. Therefore a equals b. Here a minus b equals 0. A minus b equals 0. Therefore a equals b. And a plus b, a plus b minus 5 equals 0. Therefore a equals positive 5 minus b. Here a has two values, a equals b, also a equals 5 minus b. Therefore this function is not one-to-one function. F of x equals x power 3 plus 1. I'll find f of a, which equals a power 3 plus 1. Also f of b, which equals b power 3 plus 1. I'll put f of a equals f of b. Therefore, a power 3 plus 1 equals b power 3 plus 1. I'll cancel positive 1 and the positive 1. Therefore, a power 3 equals b power 3. Then I'll take the cube root for both sides, left hand side and right hand side. Then a equals b. This is the final result, a equals b. Therefore, the function is one-to-one function. Another example, x power 4 plus 2x squared plus 1. I write f of a and f of b, a power 4 plus 2a power 2 plus 1. Also f of b, b power 4 plus 2b squared plus 1. Then I write f of a equals f of b, a power 4 plus 2a squared plus 1. And b power 4 plus 2b squared plus 1. Here I'll try to simplify both expressions. I'll factorize the first expression as a perfect square trinomial. it will be a squared plus 1 all raised to power 2 equals b squared plus 1 all raised to power 2. How can I factorize this trinomial as a perfect square? I'll find both the square root of the first term and the last term. The square root of a power 4 equals a squared. The square root of 1 equals 1. A power 2 plus 1 all squared equals b power 2 plus 1 all squared. I'll take the square root for each side. Therefore, a squared plus 1 equals b squared plus 1. I'll cancel 1 and 1. Therefore, a squared equals b squared. Here, a squared equals b squared. I'll take the square root. Therefore, a equals positive or negative b. And this function is not one-to-one function. Here a has two values. A equals b, also a equals negative b. Therefore, this function is not one-to-one function. Thank you.